Hi guys, welcome to the next part of power electronics lectures. So in our today's session, we will be starting the next part of power electronics. We all know that subject. Chapter name is called choppers, right? So in rectifiers, we have been seen plenty of questions and how to crack them. Everything we have been covered. I hope you all have understood how to approach the problems in rectifiers. In the same way, we will be approaching choppers also. So let me bring all those questions one by one. But it's time to explore everything by yourself also. Don't expect everything from my hand. If you do it by yourself, then it will be fine. Otherwise, after that, compare your solution. Suppose if you don't get the answer, compare your solution with our answer. So let me bring the first question. The question number one is, there is a chopper circuit. Okay, let us consider a chopper circuit. A chopper circuit is operating. A chopper circuit is operating on TRC. Operating on TRC principle. A chopper circuit is operating on TRP principle at a frequency of 10 kilohertz. At a frequency of 10 kilohertz, and supply voltage Vs also given as 200 voltage. Okay sir, if the load voltage is given, right, if the load voltage is 160 volt, then compute the conduction and blacking period of thyristor in each cycle. Then compute the conduction and blacking period. Compute the conduction and blacking period. Conduction and blacking period of thyristor in each cycle. Of thyristor in each cycle. Now try to read the question, collect the data, do it as fast as possible, and drop your answer in the comment section. Do it fast. Just do let me know how many of you there. Say something in the comment section. Good morning or something. Is everything is fine? I hope you people are doing. Just drop your answer in the comment section once you found the answer. Once you find the answer, okay. Do it as speed as possible, because you know I told you while solving the problem we have to be active a little bit. That's good for us. Yes. Happy to see your messages. Fine. Thank you for your response. Carry on. Drop your answer. Do it fast. What can be the expected answer for this question? You can take 2 to 3 minutes for this question. Already 1 minute is gone. Be conscious. You know how to solve the problems. Everything, just keep smile in your face. Be active and be conscious. Don't bring any unwanted things in your brain. Only focus on the question. Collect all the data. First focus what is being asked in the question. Your primary focus is what is asked in the question. That is the first one. And your secondary focus is what is the correspondent formula for that question. Write on that. Then you can find out what are all the unknown parameter, what are the known parameter. Then how to find out the unknown parameter. Just proceed step by step, you will get the answer. That is the only thing that you have to do. Read the question, collect the data, what is asked and what is the formula or what is the concept that is required to bring the answer that has been asked in the question. Collect all the relevant data, substitute it, try to bring the answer. Finish it. Okay. Anybody got the answer? 2 minutes over. You'll have only 1 minute more. Drop your answer. How many of you got the answer? Okay. Chalo. So let me try to figure out the answer. Let's see what happened. What is asked first of all? Let me go through the question once. A chopper circuit is operating at a TRC principle. What is this TRC? How many of you know the abbreviation for TRC? TRC means, it is not an unknown word, time ratio control. It is simply called time ratio control. That is the method that we are standardly using in our chopper circuits. Like how you people are defining duty cycle. There is a famous word is called duty cycle, right? So duty cycle means it is the ratio between on time upon total time. See, with respect to the time period only, we are controlling the output voltage. That is called duty cycle, yes or no? So this method is often called time ratio control. That is the standard name. So they simply mentioned that principal name here. Because of that, I know some of you might get confused. So time ratio control is, it is the standard principle that we are using in our chopper circuits to control the output voltage. Okay, we can step up, step down, or level up, whatever the things that we want to do, we can do. By we are doing all these things by leveling the time period on y-axis. Yes or no? So this is simply called time ratio control. First conclusion is over. And next, let me collect the given data. Then they told that the frequency offered by the circuit is 10 kilohertz. So they have given total frequency. So we all know frequency and time period both are reciprocal to each other. From this, you can estimate the fundamental time period offered by the circuit. That is, time taken by the chopper to complete the one cycle is called fundamental time period. So time will be 1 upon f, whereas the value of frequency is given as 10 kilohertz, to 10 into 10 power 3. So I hope it will be what? 0.1 into 10 power minus 3. Yes, sir, of course. Just to keep it as it is. Later we can write. So I know it can be written as 0.1 millisecond. If you want, you can write. So let me complete the question first. Then they clearly given the supply voltage. See there, the value of the supply voltage, it was clearly given as 200 voltage. First conclusion. And if you observe, the value of load voltage also given. The value of load voltage is given as 160 voltage. Okay, sir. Now, supply voltage is available, load voltage is available. Just by comparing these two data, is there any possible to predict what type of circuit it is? Basically, in chopper, we will be leveling up. Sometimes we will try to level up the voltage in the output. That is called step-up chopper. If you are level down the voltage, level downing means output voltage will become less than input voltage. That is called step-down chopper. In some circuits, we can do both cases. Sometimes you can level up, sometimes you can level down. So that is called step up, step down chopper circuit. Yes or no? Yes, sir. So here, if you compare the load voltage means basically we are calling it as output voltage. When the value of output voltage is less than the value of supply voltage, then this is called step down chopper. First conclusion I can made here. So from this, I can make this conclusion. The given circuit is step down chopper. In case of step down chopper, we know output voltage V0 will be equal to delta times of supply voltage Vs, that is input voltage. That is the relation between input and output voltages in case of step down chopper. Next conclusion. Now let us continue this continuous reading. Next, then the computation, to then compute the conduction and blocking period of the thyristor. It's good things to hear, right? Okay, sir. Everything is fine now. Now, what we have to do? How should I bring the answer? How can I bring the answer for this question? First of all, what is the conduction period? What is called blacking period? We know நம்ம சாப்பர் சர்க்யூட்ல எப்பவுமே டூ டைம் வந்து படிச்சுட்டே இருப்போம் எப்பவுமே ஒன் இஸ் கால்ட் ஆன் டைம் and another one is called off time. So total time is the sum of on time plus off time. This on time is nothing but what? It is the conduction time period of the thyristor. Yes or no? On time in the sense conduction period. How long thyristor will be in conduction? So on time is called conduction period of thyristor. That is called on time basically. Okay, sir. Then what is the meaning of off time? Off time in the sense thyristor is in off state, that is reverse bias. That is called blacking period of thyristor. We can call it as blacking period of thyristor. Fine, sir. Now we understood what is the meaning of conduction period of thyristor and blacking period of the thyristor. So it is basically called on time and off time. Now from the given data, let us try to estimate all this. See, everything is given. Fundamental time period T is given. Yes, sir. So you know, duty cycle delta can be defined as on time upon hold time only. So here this on time is nothing but conduction period of the thyristor. How should I find out this on time? It is very easy. How, sir? See, from this I can say T on is denotes the conduction period of the thyristor. This can be defined as delta times of T. Of course, that is true. How should I estimate the value of delta? From this expression, see there, we know the relation between output and input voltage. So we know delta equal to V naught upon Vs. Both values are given. Output is nothing but load voltage, that is 160. Input voltage is 200. So both value is given. I can substitute output voltage is 160. Input voltage is 200 into what is the total time period? 0.1 millisecond. Milli means 10 power minus 3. That's all. Now we can cancel this. You know, it will be 4 times of 4 will be 16, 5 times of 4 will be 18. So 4 by 5, of course, it will be equal to 0.8 only. If you cancel it, it will become what? We can easily cancel it. 8 times of 5 will be 40. It will be 0.8. 0.8 into 0.1 will become 0.08. So I can say 0.08 into 10 power minus 3. What is this? This is called on time period. That is conduction time period of the thyristor. Okay, sir. Then what is off time? That is very easy. Sir, how that is very easy? Because see, the overall time period is given or not? Yes, sir. Overall time period can be defined as overall time period T is equal to off time plus on time. Yes, sir. Whereas just now we have estimated the value of on time. So off time can be defined as T minus T on. I know the overall time period, that is 0.01 into 10 power minus 3 minus 0.08 into 10 power minus 3. Yes or no? I hope you all are following the lectures. So what is our next target then? So it is time to 1 minute, guys. So here I am having a small stretching. Yes, just give me a minute. I'm trying to. Okay, so you can drop the answer till then. So okay, now let us continue. 0.1 we have to subtract 0.1 minus 0.08. If you subtract, what you will be getting? I hope it will be equal to 0.2. Yes or no? Sorry, 0.1. It will be 0.02, right? Then only it will become 0.1. It will be 0.02 into 10 power minus 3. So finally, what we found here, we found that the on time, that is the conduction period of the thyristor, is equal to 0.1 millisecond, that is 10 power minus 3. And similarly, we found that the off time of the thyristor is 0.02 millisecond, 0.02 into 10 power minus 3 seconds. Am I right? I hope both answers are correct. Let me cross check it once. No, on time is 0.08, off time is 0.02. See there? On time is 0.08. Yes, off time is 0.02 and overall time period became yes. So whatever we did, that is correct. Fine, sir. Now, I hope you all understood how to do these things. How many of you got this answer? It's okay. It's okay, no problem. Slowly by practice, everything will become easy. You will be able to solve all type of things. Okay, sir. So let us move on to the next question. So let me bring the second question. The second question is a DC chopper circuit. Just note down a DC chopper circuit. A DC chopper circuit connected to a 150 voltage DC source. It means it is connected with a supply 150 voltage DC source. It is connected and connected with the 150 voltage DC source supplies. It is supplies an inductive load. It is supplies an inductive load having 50 millihenry inductance and in series with the 10 ohm resistance. In series with the 10 ohm resistance. That is the next given data. Now, a freewheeling diode is placed across the load. A freewheeling diode. A freewheeling diode is placed across the load. A freewheeling diode is placed across the load. Okay, sir. That is the given. And load current is varies between the limits. Load current varies between the limits. Let me write down like this. I am directly writing the answer. Load current limit was clearly given as 10 ampere to 15 ampere. That is the given limit of load current. Now determine the time ratio of the chopper. That is, the question is, what is the ratio between on time and off time of the chopper? That's all. That is the given. Now you can try this question. As usual, you can take some time. Sugumori, good. Last question. You get given the answer. Now take this question again. Read the data properly. A DC chopper circuit connected to a 150 voltage DC source supplies an inductive load having 50 millihenry, and it is connected in series with the 10 ohm resistor. If a freewheeling diode is placed across the load, then the load current variation they have given, it's running between 10 ampere to 15 ampere. Then what is the expected ratio between the on time and off time of the chopper circuit? Okay, take your time, try to figure out the answer. Okay, think it by yourself. No need to think too much, but it's your responsibility to bring the answer. First you have to figure out what type of chopper it is, right? Okay, you can think it. I don't want to disturb you guys. Think it by yourself. What type of chopper it is? Suppose if we don't know the what type of chopper, then how can we figure out the type of the chopper? Think about it and try to figure out the answer. Got the answer? First identify what type of chopper it is, then the operation will become very easy. I'm repeating one more time also. Whenever you are collecting the data, your step number one while solving any question, first read the question and keep your attention with the question what you are being asked to solve. First, collect the data which is relevant to the question. In this case, you are requested to calculate the ratio between on time and off time. So, in order to calculate that ratio, so we must know the value of on time and off time. So, how to calculate the on time and off time? What type of relations that are required? You should develop the question like that. So, instead of that, if you are sitting and collecting all the data, inductor value is given this much, sir, resistor value is given that much, sir, if you are doing research on it, it will become useless, because in sometimes I have been told many times they will be giving you some unnecessary data just to confuse you all. It's not because just to make you confused. Many of you people will avoid whenever you are seeing all these values. You people are thinking that whatever the data that is there in the question, it's all required to solve that question. No, it is not mandatory. It may be true in some cases, but it may not be true in some cases. So we can't give a surety. That's why I'm asking you to focus on only on the question instead of what I can say doing research on the given all data. Only focus on the question. Okay, the question that are asked is the ratio between on time and off time is what. So how should I figure it out? That's all. Only keep your attention on it. Okay, sir. I hope I had given sufficient time for you all. Let me try to figure it out. Let's see what might be the answer. See, I'm reading the question first. A DC chopper circuit connected to a 150 voltage DC supply. So they have given supply voltage Vs equal to 150 voltage. I know this is mandatory data because in a chopper circuit, output voltage, input voltage are very important. Without having them, you should not predict out. So supply voltage is very important. But they have given the value of inductance also. For this question, according to the given data, I don't think that is required. Sugumari 1.94. Very good, very good. Let's see. So supply voltage is 150. Then we have to figure it out what type of circuit it is. So what should I do that for? What can I do for that? So I'm just thinking about it. Let us continue. Then connected DC supply. It is connected to 150 voltage DC. So supplies an inductive load having 50 millihenry and a series of 10 ohm resistor. See, you all know the purpose of connecting the inductor and capacitor in chopper circuit, because related to this, why we are connecting capacitor and inductor in chopper circuit. For this, I had given the answer already in rectifier circuits itself. Why? Inductor is helping us to produce the continuous current at the output side in order to get the ripple free current or continuous current or constant current. Ripple free, if we want to make the output current is ripple free, then inductor presence is very important. Second thing, if you want to make the value of output voltage V naught as ripple free, then you must keep the presence of capacitor. That's why we are maintaining these two people. So what will happen is this inductor will be started behaving as a short circuited one. Sir, why? Why it is behaving as a short circuited one? Why? Because we are dealing with a chopper. In chopper, both input and output are being treated as what? DC supply. When an inductor is permanently connected with a DC supply, with a DC source, what will happen? Inductor behavior will become short circuited one. Basically, it will be behave as a short circuited one. Similarly, when we are connecting a capacitor with the DC supply, definitely there will be some ripple current will be there. Some transient effect will be there. That's why we people are calculating the value of del V, del I at all. That is ripple current and ripple voltages. It will be there. I am talking about steady state properties. Don't think that it is always zero. The voltage across the inductor is always zero and the current flow through the capacitor is always zero. We are considering they are changing their properties time to time. So I'm just talking about that steady state properties. Conclusion is we are talking about DC voltages. So in the output side, though we are having the presence of inductor, during the calculation you no need to consider it. When you are calculating the output voltage, output current, it will be simply behaving as a short circuited one. So it is not mandatory to evaluate the properties of inductor directly. But inductor, you can use this inductor to know the output current. Basically, this inductor is only dealing with the output current. How to calculate the output current? Capacitor will be dealing with the output voltage. If capacitor voltage is given, that will be equal to output voltage. If inductor current is given, then that will be differ to circuit, because this capacitor always permanently connected in parallel to voltage. But inductor position will be different from chopper circuit. In step down chopper, it will be placed at one point. In step up chopper, its position is different. So based on the position of the inductor, the current flow through the output will be different, will be differ. I can't say we can use the same formula for all type of chopper circuit. But for in case of capacitor, capacitor is permanently connected across the output in all type of chopper circuits. So if capacitor voltage is given, you can treat it as a output voltage. If output voltage is given, you can say output voltage will be equal to capacitor voltage. But this will not be true for inductor. In case of inductor, you should check what type of chopper circuit is given. I hope you all know this basic things, because it is there in the lecture, right? Fine, sir. So output voltage is given. Now you know the purpose of inductor and capacitor. I understood that inductor is given just to show that they have connected the inductor to produce the ripple free current. So next what happen is, because of this, current is not reaching zero. If you observe, they have connected the inductor. Because of that, current is varying between 10 ampere to 15 ampere. Again it is going down to 10 ampere, it is going up to 15 ampere. Again it is going to 10 ampere, going up to 15 ampere. So this is the maximum and minimum current. Okay, sir. Then how should I express the average value of the output current? That is the next question. It is very easy now. So we need, see, basically whatever the parameter that we are calculating, output voltage means we are defining average output voltage only. Output current means that is average output current only. If I am giving output current as two values, like minimum value is 10 ampere, maximum value is 15 ampere, then how will you calculate the average current? If I know the minimum and the maximum value directly, then calculating average current will become very easy. How? So I'm just asking you, in your first quarterly exam, you got some 400 marks out of 500 in your 10th standard. In your second half yearly exam, you got some 450 marks out of 500. Now, one of your faculty entered in your class, and he is asking you to calculate the average marks scored by you in the both of this examination comparatively. What will you do? You add, okay, in the first exam I got 400, sir. In the second exam I got 450, sir. To calculate the average, I have to divide it by number of samples. First sample, second sample. So that there are two samples. So what will you do? So it will be 950 divided by 200. Yes or no? So this is going to be your average. If we cancel it, what will become? 4 times of 2 will be 80. 7 times of 2 will be 14. Again 5. So what will you do, sir? My average score is 475. When I am adding these two, I am getting this one as my average mark. Yes or no? Sorry, it is 850, right? 850. Forgive me. Sometimes I will do this kind of silly mistakes. 4 times of 2 are 18. 2 times of 2. Again, it will be 7 times 5 times. So 425 is his average mark. So average means basically it is the addition of lower value and higher value when both data is given. So it is very easy to predict. What you can do is minimum value of the inductor plus maximum value of the inductor current, load current. Here both are in series, so both current will be same only. So minimum current through the output and maximum current through the output divided by 2. This is called average output current. So when both are given, 10 plus 15 upon 2 will become 12.5. See, 10 into 15 will be 25. 25 by 2 will give you 12.5 ampere. So we found the value of average current. Sir, why are you unnecessarily calculating this? I don't know, but my mind is just stucking with what type of chopper it is. Without knowing the type of the chopper, I cannot directly write down the relation between the input and output voltage. If we can't write down the relation between input and output voltage like the previous question, then see how we will solve the question previously. First, we found that between the relation output voltage and input voltage, we found that the given circuit is step down chopper. Then from that step down chopper, I wrote the relation between input and output voltage. Then we calculated the value of delta. From that, we were estimated the value of on time and off time. So in the same way, I just wanted to proceed this question also. For that, I wanted to know the output voltage. So what I am thinking is, anyway, this inductor behavior will be short circuited in the output, but they have given the output resistor value. So indirectly, if I know the value of resistor and the current flow through the resistor, is it easy to calculate the output voltage or not? According to Ohm's law, average value of the output can also be estimated in the alternative way. How? Output average current into resistor. That's all. It is very simple now. So 10 into 12.5 ampere will be giving us 125 voltage. So now you can compare the input voltage is 150 whereas the output voltage is 125. So it clearly denotes that the supply voltage is greater than the value of output voltage. So whenever the output voltage is less than the input voltage, that is called a level down voltage, or we can call this circuit also by giving us a step down chopper. Wow, we are feeling happy now. As usual, again we got the step down chopper only. Okay, sir. So step down chopper is given to us. So how can we proceed further? Now it is time to explore everything. See, let's see. Let me try to bring out the answer. So what we can do is V naught equal to Vs into delta. First conclusion we know from this. I know output voltage we got 125, whereas the input voltage is 150 times of delta. So from this, delta equal to 125 upon 150. I hope we can cancel it by 25. See, 5 times of 25 will be 125, whereas 6 times of 25 will be 150. I can write this relation as 5 by 6. Just keep as it is. It will be helping us to reduce the equation easily. Steps. Okay, just I'm keeping it as numerical. I'm not reducing it further. Okay, so delta value is 5 by 6. That is what we got. Now we know delta can be replaced by on time upon total time. So this will be equal to 5 upon 6. Yes, sir, exactly that is true. And this one can also be written as, see there, I'm slowly evaluating. Can we take the reciprocal for this? I'm just taking the reciprocal. If I'll take the reciprocal, then T will come to the numerator and T on will go to the numerator denominator. Shall I write like this? Sir, why you have replaced T by T of plus T on? I'm just taking the reciprocal first. If we will take the reciprocal, then 5 by 6 will become 6 by 5. In the same way, take the reciprocal for these two, then T will come to the numerator, T on will goes to the denominator. Then T can be replaced by, basically T is the fundamental time period of one cycle. So it is the addition of off time and on time. Now we can write like this, off time by on time plus on time by on time will be 1. Can I write like this? Yes, sir, equal to 6 by 5. Now you can pass this 1 to the right hand side, then it will become 6 upon 5 minus 1. Take the cross product, it will become 6 minus 5 by 5. So it will become 1 upon 5. What is this? This is the ratio between off time to on time. Is it the question? I don't know. Let us check. See, the question is what is the ratio between on time to off time? See how beautifully they have asked the question. So if I will take the reciprocal for this one more time, I will be getting 5. Geeta, yes, you got the correct answer. I'm really happy. Right. So this is how we are getting the answer for the given question. Chopper is very easy. Very, very easy actually. So little practice is required. Chalo. Let us go ahead with the next question. As usual, try to bring the answer for the question. Okay, let me drop the next one. So, and question is ideal an ideal chopper operating at a frequency of, given it is, they have given 1 kilohertz. Okay, an ideal chopper operating at a frequency of 1 kilohertz, whereas the load resistance RL is given as 5 ohm and inductance also given as usual. The value of inductance is 10 millihenry. So and the supply voltage is given Vs. The supply voltage, an ideal chopper from here 60. Okay, yes, 1 minute guys. Supply voltage is given as 50 voltage. Okay, now the mean value of load voltage. Question is mean value of load voltage. What is the meaning of mean value of load voltage? The question is what is the mean value of load voltage? VL mean means mean value of load voltage for on to off time ratio they have given. For the on to off time ratio of 5 by 1, that is given. Okay, that's all. Anybody, take your time. Once again, I'm not going to force you to do anything. Take your own time, but try to drop your answer. What can be the answer for this question? An ideal chopper is operating, everything is given. Circuit is ideal, first of all. It means lossless circuit. Then sorry, load voltage, mean load voltage அப்படினா meaning என்னங்க? What is the meaning of sir mean load voltage? You all know mean means what? Sir, mean means average, right? So mean means average. So an ideal chopper operating at a frequency of 1 kilohertz, load resistance is 5 ohm, inductance L equal to 10 millihenry, supply voltage is given as 50 voltage. Then what can be the expected value of this average output voltage for the on to off time ratio of 5 by 1? It's good, right? Let's see how you people will be dealing with this. Let us see your ability. I just wanted to know how you people are solving this question. Everything is given in a perfect way, but you must. Anyone got the answer? If you got the answer, just drop it in the comment section. I'm waiting for your answer only. Got it? Try what other people are doing. I think there are so many people, but none of you giving the answer. I don't think this will take that much time. No one? Okay. See, every time they are telling that, sir, the inductor is connected in series with the resistor. Here also, I told the same, right? If you observe the circuit, there also what they told, they had given that the inductor is connected in series with the source directly. When the moment you are observing these things, you can easily guess what type of circuit it is. That's not a big deal for you all, I think. Right? Fine, sir. See, 125 voltage. Very good. Any other? Kanaga Savita. Good. Okay. Let me try to figure out the answer from my end. So it's an ideal chopper, and they told that the resistor is 5 ohm and inductor L equal to 10 millihenry, and we are supposed to calculate the value of output voltage. So to know this, what can we do? In this case, the value of average current at all not given. Geeta 58. Good. Let's see. I also don't know. Or let me try to explore the answer for this question. So what they given is on time to off time ratio they have given. Simply they are asking the output voltage. Basically mean voltage means that is simply called average output voltage. Load voltage means that is basically output average voltage only. So they are asking what is the output average voltage. So the formula to estimate this value is delta times of supply voltage Vs. Okay, sir. It is delta times of supply voltage. Whereas we know delta can be defined as on time upon total time period. It's not like on time upon off time. Directly we should not define that. So what we need is they have given on time to off time ratio, but we need is on time upon total time period, fundamental time period. What should I do, sir, for this? How can I explore it? How can I bring the answer? See, what I'm doing is I'm exploring like this. My mind is just blowing in this way. You can follow your own method. They have given on time to off time equal to 5 by 1. So what I wanted to do is I will take on time upon off time. I'm just trying to add plus 1 on both sides. Sir, my mind is thinking in that way because from this relation I'm trying to bring the value of delta. You can follow your own method. Kali 1 into 50. Good. So let's see. What I'm doing is when I'm cross producting these two terms, it will become on time plus off time upon off time equal to same way. If you do the cross product, 1 into 1 will become 1 only. So 5 plus 1 will become 6 by 1 overall. Now we can say this T on plus T off total, it will be fundamental time period T upon T off. So what we found is total time period upon T off is equal to 6 by 1. If I take reciprocal, then I can say off time upon total time period equal to 1 upon 6. Or I can say from this, what we can define is we can say that the value of time period offered by the circuit equal to 1 by 6 times of overall time period, whereas they told the overall time period where, sir, where overall time is given, they have given frequency. We know fundamental frequency and fundamental time period both are reciprocal to each other, sir. So here I can replace this t by 1 upon f. So it will be 1 by 6 into 1 upon the value of f is given 1 kilohertz. Kilo means 10 power 3. So I can rewrite this one as 10 power minus 3 upon 6. We know when we are bringing this 10 power 3 to the numerator, it will become 10 power minus 3. So we figure out the value of half time only. From this, what I can say, sir, from this we can say total time period is defined as on time plus off time. So on time plus off time equal to 10 power minus 3 upon 6. Yes or no? Yes, sir. Now here I know the value of T on. Guys, 1 minute. Here I did a mistake. See, total time period is T on plus T off. That value is 1 into 10 power minus 3. 1 millisecond only, no? So from this I can say T on equal to 1 into 10 power minus 3 minus T off can be replaced by 1 upon 6 into 10 power minus 3. So you can rewrite this cross product of 6 into 1 will become 6. 6 minus 1 will be 5. So 5 by 6 into 10 power minus 3. This is the on time. Now you can come back to the V0 average. So VL average can be estimated from this. We can write that is load average output voltage, or we can say output average voltage V0 average equal to on time by off. See, delta times of Vs. Delta equal to on time by off time, whereas on time is, sorry guys, on time is 5 by 6 into 10 power minus 3 upon, not, it is total time period, right? Total time period is what? Total time period is simply 1 into 10 power minus 3 only. So 10 power minus 3, 10 power minus 3 will be cancelled out into input voltage is, it was given as 50. I can say this will be equal to 250 voltage. 5 times of 5 will be 25. So 250 voltage upon 6. Let us cancel it. We all know 4 times of 6 will be 24. Remainder will be 1. So again, if I will cancel it, I am getting 1 times of 6. Remainder will be 4. So I have to keep fraction here in order to cancel it. So it will be 6 times of 6 will be 36. Again, remainder will be 4. One more time. So it will be 41 point. Approximately it will be equal to 41.67 voltage. So this is how we are estimating the value of type of the circuit. See, listen, in this circuit, they simply told that they are considering one ideal chopper and it is operating at a frequency of 1 kilohertz and an inductor is connected in series with the resistor 5 ohm. I haven't written that statement here. They told that the inductor is in series with the 5 ohm resistor, and they told that supply voltage is 50 voltage. So by default, I'm assuming when inductor is connected with the DC series with the resistor, so it is acting as a step down chopper. Okay, so because see they haven't given any other data in the question, on to off time ratio only they have given. So if any other circuit is given in your circuit, it will be mentioned. Like in the last other two cases, they have given the clue to identify what type of circuit it is. But in this case, if they have given only general circuit, general chopper circuit will be behaving as a step down chopper only. General chopper circuit, very first we were designed a general chopper circuit. So here they have given general data. Whenever general data is given, you first cross check whether the sufficient data is given or not in order to identify what type of given chopper it is. If the sufficient data is not given, then cross check whether they given the inductor properties to connect it in series with the resistor or not. If that is given, then again you can take. If this is also not given, only resistor is given and they are telling that it is ideal chopper circuit, then directly in that case also you can treat that given circuit is step down chopper. I'm repeating one more time. Whenever the question is given, first try to identify the type of the chopper with the given data. If the data sufficiently not given, then cross-check whether the inductor and the resistor are connected in series or not. In that case, if it is connected in series, then also you can easily identify that the given circuit is step-down chopper circuit. Otherwise, if they are giving some other clue, like inductor is connected with the switch or it is connected in diode, with the freewheeling diode, like that, if some other clues is given, in that case, you must remember the circuit, equivalent circuit of the step down chopper, step up chopper, step up and step down chopper. If you do remember the equivalent circuit in your mind, then it is very easy to predict the nature of the circuit. Because if you remember, then when the moment they are giving the data, this is connected in series with this, then you can easily identify what type of circuit it is or circuit it is. If there will be no any information about like that, just they have given there is an ideal chopper and this is the input voltage, this is the frequency, this is the resistor, this is the on time off time. In that case, you can treat that circuit as the step down chopper generally. Okay, I hope now you people might got the conclusion about it. Chalo. Now it is time to explore the next question. Let us move ahead. Sorry, go ahead with the next one. I'm bringing the next one here. 1 minute. Yes. So what is given is for, once again, for the ideal chopper shown in figure, for the ideal chopper shown in figure, for the ideal chopper shown in figure with the, what they told is with the supply voltage Vs is given as 200 voltage, output voltage V out is given as 100 voltage, and load current IL is given as 20 ampere. The RMS value of the load current. Now the question is, what is the RMS value of the load current in the freewheeling diode? It is flowing through the freewheeling diode. What is the RMS value of the load current that is freewheeling through the diode? Freewheeling through diode. Once again, I will draw the circuit, don't worry, because they told that data is shown in the figure, right? Yes, you should observe that. So what they told is they have taken, sorry, we are in DC. They have taken on DC source here, positive and negative polarity, then it is connected in series with one inductor, and they kept one capacitor directly. Then they kept one switch here, then they kept one diode here, they are calling it as freewheeling diode. Then again they have connected one more inductor here, then They are telling that this is the point where they are going to measure the output voltage V0. So now this inductor value is simply given as L both are same, and they told that this is freewheeling diode, this is capacitor C, and this is supply voltage Vs, this is output voltage V0. So here through this circuit only they are considering that load current. I hope you understood the question. The RMS value of the current in the freewheeling diode, the RMS value of the load current, the RMS value of the load current through the freewheeling diode. Sometimes the output current will be flowing through the freewheeling diode. Sometimes the output current is flowing through the supply. So now the question is, you have to identify the RMS current which is flowing through the freewheeling diode. Take your time again, bring out the answer. Okay, don't think too much, because chopper circuit is completely related with the basic network analysis. Everything will be given if you know KCL, KVL, Ohm's law, everything properly, and the basic fundamental properties of inductor, capacitor, resistor, whatever that we have gone through in our basics of circuit theory, that will be sufficient to crack all questions. So it's time to explore everything by yourself. Let's see how far you people is going to bring out the answer for this question. So there are so many data is given. You can easily identify the type of the chopper circuit. Mm, so in between at what condition your circuit is working, it's very easy to identify that. I know many of you know the formula. This it's a direct formula, right? RMS current through the freewheeling diode. Knowing everything is very important. Whenever you people are discussing about current, then think about all inductors, because basically inductor is helping us to get the continuous current. Capacitor பத்தி எப்போ நம்ம பேசணும், you should keep your attention on the capacitor when we are discussing about voltages, because voltage is helping us to maintain the output voltage is constant. Inductor is helping us to maintain the output current as constant, okay, ripple free. Got the answer? 16.37 ampere, Geeta. Good, very good. Any other? People are doing great job. Okay, let me try to explore the answer. Sir, what they told is, for the ideal chopper shown in the figure, supply voltage and output voltage is given, output current also given, and they are asking what is the RMS value of the output current. Fine, sir. If you take the circuit, there is a switch. See, this is the switch. How this circuit will work out? Let's see what will happen. I am drawing the waveform here itself directly. See, our attention is with the current only, so I'm just going up with the current. Remaining things are not required here. Kindly go through our lecture once, because I have taught this all things in a proper way, step by step I have approached. So no need to revise here. You can just go through and you can easily understand. Anyway, inductor is there. The presence of inductor, we know inductor will be helping us to produce continuous current. Continuous means it will not touch a zero crossing point. Fine, sir. So I'm just assuming that it is starting from somewhere here, initial value, or otherwise very first when we are starting. See, first what will happen? We will be closing this switch for particular some time period, that is called on time period or conduction period of the thyristor. When the moment you are switching on this thyristor, what will happen? Immediately the supply will started delivering the current through the what? Through this inductor, and then this inductor, then like this, it will be going like this, because this positive voltage, anyway this inductor will be short circuited within few nanoseconds or microseconds, because we know when inductor is connected with the DC supply, instantly it will not accept, but within some time, slowly what will happen, it will be started behaving as a short circuited one. So directly we can bring the relation between input and output voltage. Under this situation, if you observe this freewheeling diode, this is anode terminal, this is cathode terminal. If you focus carefully, supply voltage is having positive negative polarity like this, and it is directly connected with the diode in this manner. See, here the negative polarity will get reflected across the anode, positive polarity will get reflected across the cathode. Since this diode will be behaving as a off circuited one, so it is, I can say it is simply behaving as a open circuit. This is first case. So in that moment what will happen is switch is turned on, current is started charging. So this inductor is slowly accepting the changes. Because of this, if you observe, the output current is slowly charging. Remember one thing, sir, how you are starting directly from some values, why it is not started at 0? Very first time when the moment you are switching on this circuit, what will happen is it will be starting from 0. From the next cycle onwards, it will have certain amount of initial residual current. You know, in electrical machines also, our coil is designed with the help of inductor only. So copper coil, it is resembling the properties of inductor. So this coil is having retentivity. It will store the energy. Particular amount of energy will be stored inside the inductor. That is called residual energy. So that residual energy will keeps these things will not get 0. It will maintain certain positive value here. So from the next cycle onwards, you can observe some minimum value of positive current, then it will be going up to maximum value. Now what will happen is, till the moment you are trying to switch on this circuit, I am trying to maintain this on state for a particular 2 or 3 seconds, 4 seconds, whatever. So till the maximum point of your on time period, on time, suppose if it is 10 millisecond, till that point your inductor will be continuously charging and it tries to achieve the maximum peak current. Then when the moment you are switching off this circuit, what will happen? See, you know, initially inductor was behaving as a short circuited one, and it was trying to store the as much energy as possible inside it. Inductor will be charging, you all know, but its behavior is short circuited one, but current will be there. Inductor is short circuited one, see there, when inductor is behaving as a short circuited one, current will be flowing through that. Inductor is keep on charging, so energy across the inductor will be continuously increasing. We can say of Li square, see there, square times of current will be there. So inductor energy will be proportional to square times of the current. As long as you are supplying the energy continuously from the source, inductor will be continuously charging up to its maximum value. So current through the inductor will tries to reach maximum as peak as possible. Okay, sir. Once you disconnect the supply, if I will open this switch immediately, what will happen? Then inductor will stop charging. Why? Initially, your inductor was being charged with the help of source. Now, when the moment you are removing this switch, immediately your inductor will stop charging. Then what it will do? Then it will tries to behave as a source and it will deliver the energy. It will try to give the energy to someone. So as long as your inductor is connected with your source, as long as your inductor is connected with your source, it will be charging. When the moment you are disconnecting the source, immediately it will started discharging. It will act. Now inductor will started working as a source. Sir, how inductor will work? I told you. I hope you all have remember. Anyway, let me recapture once. Listen. You cannot reverse the direction of the current through the inductor. Suppose when the moment your inductor is connected with the DC supply, if your current is going in the downward direction, when the moment your inductor is charging, it is acting as a load, yes or no? Like our mobile battery. First we are charging our mobile, then we are disconnecting the battery. Sorry, we are plugging up. Once you remove the mobile from the supply charger, then the battery that is stored inside the mobile will be acting as a source, and that is feeding the power to our mobile. That is how inductor will be behaving. During this process, what will happen is, when inductor is charging, it is acting as a load. You know the basic property of load. Load means current entering point will be plus, leaving point is minus. So this is the initial polarity of the inductor, and the current will be in downward direction, we know. Once this supply is disconnected, then what will happen? The energy that is stored across the inductor will started freewheeling. So it will act as a source. When the moment it is started acting as a source, I told you direction of the current should not be reversed. Again, it will follow the same direction, downward direction. But it has to act as a source, right? If you want to make it as a source, for a source, current entering point should be minus, leaving point should be plus. Yes or no? That is the property. For a load, current entering point plus, leaving point is minus. For a source, current entering point minus, leaving point is plus. So when it is started working as a source, when it is started acting as a source, it starts reversing its polarity. First, it will reverse the polarity, then it will discharge this energy up to its maximum possible values. இதுலயே discharge ஆகும். See there, you have disconnected this switch. Once this switch is disconnected, then what is the point of having the return path? There is one inductor, but the switch is disconnected, and you are having the DC supply. Of course, you are having one more path to return, but one path is blocked. So when forward path is blocked, the return path will not work. So what will happen? The energy that is stored across the inductor will starts. It will come, this energy will come here. Let me show it separately. See, now if you are keeping your attention with the only inductor, you can easily observe this. See there, I told you initially our inductor was charging. When it was charging, current entering point plus, leaving point is minus, right? This is when it was charging. But now your inductor will going to discharge means polarity. This will become minus, this will become plus. But for the inductor, direction of the current will not get reversed. For the capacitor, polarity of the voltage will not get reversed. That is the basic property. So this inductor current will be again remains in the same direction. It will tries to come in this way. After that, it can't go here because in the upper path here we will have a open circuit. So here current will not come. So according to KCL, if the incoming current is 0 from here, then the outgoing current also must be 0. So this current will not go in this direction. So this current will start traveling through here. That is the first one. And second conclusion, polarity is reversed now. See that this positive polarity will get reflected across the anode. This negative polarity will get reflected across the cathode. So this diode will turn on. So it will be short circuited. Once it is short circuited, then what will happen? The energy will start at freewheeling, and it will be keep on getting dissipated across the load. But what you have to understand is, if this freewheeling diode is completely short circuited, see, diode is ideal one. They haven't given any voltage drop across the diode. If your diode is ideal one, then there will be no any voltage drop. If it is turn on state in the sense short circuited. So between these two terminals, there is one short circuited line. Short circuited line means what is the voltage across that line? It will be 0. If this one voltage is 0, then output voltage also, so in this, sorry, total voltage between these two terminals will become 0. The overall voltage, I can say overall voltage, not output voltage, because output voltage is across here. Overall voltage means it is the combination, addition of inductor voltage plus resistor voltage. See, now inductor is acting as a source, load is acting as a load only. So source voltage plus load voltage will be equal to 0. That is Kirchhoff voltage law. So KVL will be satisfied here. Yes or no? So that's all. So what we have to understand here is, so the polarity of the load voltage and the polarity of the inductor voltage will be opposite to each other. It's all, am I memorizing anything? I'm just analyzing. This is the way you should do, because in sometimes some general circuit will be given in your examination. At that time, some general circuit also will become under the category of step down or step up, step down chopper only. But when we are looking into some generalized circuit with some twisting they will give in the examination, you people will be worrying about it. Oh, I don't know, actually I know only basic formula for the basic chopper circuits. I don't know how to approach this. So this is wrong. So try to generalize the procedure. It doesn't matter whether it is standard circuit or a newly designed one. If you know the basic procedure, you can play with these circuits. That's very important. Let us continue. Okay, sir. So as long as we have understood that in the second process. So now what will happen is inductor will be continuously discharging and the current will be flowing through the freewheeling diode. Let us come to see. Now what will happen? Initially your switch is on. Current through the load was continuously charging. Now your current is discharging, but this discharging will be happening through freewheeling diode. Freewheeling diode is on now, switch is off. Yes or no? This is off time period of the thyristor. So it will go up to certain value, minimum value. I told you the residual property of the inductor will not make the inductor energy as zero. It will maintain certain minimum value. From there again, see, this is one cycle. It get come in this one cycle, which is called on time period. On time period basically talking about the conduction period of the thyristor. So this switch is in on up to this point. That is when inductor is charging up to its maximum value. In off period, freewheeling diode, through the freewheeling diode only current is freewheeling here and energy will be keep on decreasing because the energy is getting dissipated through the load. Again, what will happen in the next cycle? Again, inductor will be charging up to maximum value. Again, it will be discharging. Again, it will be charging up to maximum value. Again, it will be discharging. Same process you can observe all type of chopper. It doesn't matter what type of chopper circuit that we are using. But see there, because of the presence of the inductor only, we are getting continuous current. Whether your energy, whether your inductor current is touching zero crossing point or not. No, it is not touching x-axis. It means the current is not becoming zero. So we are trying to obtain, see, almost we need pure DC, but this inductor is, if you again increase the value of inductor, then what will happen? This charging time period will decrease. Almost they will started producing some continuous current. Almost it will become ripple free. 100% is not possible. At least we will try to get close to the maximum ripple free value. Okay, sir. Now I hope you all have understood how it is working here. Come to the conclusion. The question is the output current that is freewheeling through the diode. Now you know freewheeling action will be fall in place only when switch is thyristor is in off state. Only. So this is off state period of the thyristor, blocking period of the thyristor. During this period only our what I can say, we are observing the current, output current is traveling through the freewheeling diode. Now how will you explore this current? Let me tell you. So what we understood here is, we understood that first it is charging through the switch, then it is discharging through freewheeling diode. So the conduction period of the freewheeling diode is, it is nothing but off time period of the thyristor. Yes or no? When thyristor is blocking, then output current is started freewheeling through the freewheeling diode. Okay, sir. So this is the on time period of the thyristor. Fine. Everything is fine now. How will you explore? They told that now, they told that the value of output current I naught is fixed. Do you remember the value of average output current? They told what is that? Yes, let us come see. The load current is 20 ampere. Average current means, you know, minimum value plus maximum value divided by 2 is called average current. I already told you the meaning of average. If the minimum and maximum value will be given, then minimum value of the load current plus maximum value of the load current. Instead of L, you can also keep output current. Nothing is wrong. Divided by 2. Instead of L, you can also keep output current or load current, both are same. So minimum value plus maximum value divided by 2. That is average current. That average current will be constant. It will be going like this, flat. So now I am taking this current because that is what given in the question. They have told that this current value is 20 ampere. Okay, sir. So first, let me take the load current alone separately for a better understanding. Load current is first traveling through thyristor up to on time period. After that, same current will be traveling through what? In the off time, it is traveling through the freewheeling diode. Maximum current will be 20 ampere. And fundamental time period, overall time period is T. Now the question is, calculate the RMS current through the freewheeling diode alone. இப்போ நான் உங்களுக்கு freewheeling diode மட்டும் நான் current வரைய சொன்னேன் அப்படின்னா நீங்க எப்படி வரைவீங்க? Freewheeling diode மட்டும் நான் current கேட்டேன் அப்படின்னா, sir, during the on time, current through the freewheeling diode is 0 ampere. Yes or no? Overall output current is continuous. It is going like this. First it is going through switches, then it is again going through freewheeling diode, again it will go through switch, again it will go through freewheeling diode, but the output current will be continuous. But if I will keep my attention only with the freewheeling diode, during on state, when thyristor will be in conduction, current flow through the freewheeling diode will be 0. When diode will be in conduction, freewheeling diode will become, see, can I draw like this? So 20 ampere will be flowing through the freewheeling diode when thyristor will be blocking the input. Again on state, again off state. So this is how we are drawing the waveform for the freewheeling diode current. Now the question is, you know the overall time period. We always have to consider the overall time period of the output. Overall time period of the output is T. 50% it is traveling through second, that is a freewheeling diode, remaining traveling through on time, sorry, switching circuit. Okay, sir. Now, how will you calculate the average value of the freewheeling diode? I just wanted to know the average value of the freewheeling diode. See, it can be estimated as in terms of output current. See, basically here this current is output current. This output current is flowing through the diode. How will you write down this formula? Let me tell you. Simply I will write average means you all know area by time period. That is very simple. T denotes the overall time period. So I can say this is fundamental time period. But here for the on time, width is 0. Sorry, height is 0. Current will be 0. Width is only T on. So how will you write 0 ampere current into T on? It is rectangular only, right? Area, how will you calculate? It is a rectangular box. So width into height will give you the area. Second case, off time into current value is 20 ampere. I am generalizing. I will be considering I naught here. I naught average. That is average value of output current only. I naught average. We can also write like this. Or you can keep simply I naught. Nothing is there. See, first point is 0. So I can say off time period divided by overall time period into output current I naught will give you the value of freewheeling diode average current. Okay, sir. Suppose if I want to know the value of RMS current, then what will you do? This is average current that is flowing through the freewheeling diode. Now you can substitute off time, on time. Do you know the value of off time and on time? Any clear clue is given for that? Do we need to estimate? Yeah, supply voltage and output voltage is given. From this, we can calculate the value of delta. That is the ratio between on time to total time period. We can estimate here, right? Okay, sir. But we must know the value of off time, sir. How do I do that? Wait, I will come to that conclusion. Don't worry. Here, I hope you understood how to analyze this circuit. That is very important. ஏன்னா எல்லா டைமும் வந்து ஃப்ரீவீலிங் டயோட பத்தி பேச மாட்டாங்க. இப்போ இந்த டைம்ல உங்களுக்கு தெளிவா புரிஞ்சிருக்கணும் how to draw the waveform, how to calculate the average current through the freewheeling diode. இப்போ இதே மாதிரி நான் வந்து question வந்து switchக்கு கேட்டனால உங்களுக்கு பண்ண தெரியணும். That's very important. Okay, sir. Now, how will you calculate the RMS value of the freewheeling diode current? RMS value நான் ஏற்கனவே சொல்லியிருந்தேன். What we have to do? RMS means root mean square value. அதாவது என்ன பண்ணணும்னா ஏரியாவை எடுத்துக்கிட்டு அதே அவுட்புட் கரண்டோட வேல்யூவை ஸ்கொயர் பண்ணிக்கிட்டு இன்ட்டு வித்தால மல்டிபிள் பண்ணும். ஆஃப் டைம் மட்டும்தான் வரும், ஏன்னா ஆன் டைம்ல கரண்ட் 0 டிவைடட் பை ஓவரால் டைம் பீரியட். ஸோ திஸ் இஸ் சி தேர் மீன் வேல்யூ ஏரியா பை டைம் பீரியட். மீன் ஸ்கொயர் அப்படின்னா மீன்ல மேக்னிடியூடோட வேல்யூவை ஸ்கொயர் பண்ணணும். தென் மீன் ஸ்கொயர் அப்படின்னா யூ ஹாவ் டு டேக் தி ரூட் ஃபார் தட். I'm repeating one more time. Mean means average. Average na area by time period. Area width into height. I have written that. Then mean square. Square means magnitude of the height is square. No. Next other paniyacha. After that I should take root. That is what I did. That's all. So from this I can write. So freewheeling diode RMS current. I naught square will come out of the root. So I can write this one is T off by T whole power 1 by 2. Sir, now I don't know output off time period. I don't know, sir. How do I estimate this value? Let's see. Basically, you might have observed that the value of output voltage is less than the value of input voltage. Yes or no? Just now I saw that. See, this is 200. This is 100 voltage. So the value of output voltage is 100, whereas the value of input voltage is 200. It means what? This circuit is behaving as a step down chopper. For a step down chopper, we know as usual output voltage V0 can be delta times of, it can be written as Vs. Okay, sir. V0 is given as 200, Vs is given as 100 equal to delta. I am just passing this Vs to the left hand side such that I can say delta equal to, am I right? Sorry. Output is 100, input is 200. See, Vs equal to 200, V0 is 100. 100 by 200, it will be 1 by 2, or we can say 0.5. Sir, delta we know, sir, but we want to know the ratio. Wait, I will tell you. Delta can be replaced by T on by T or not? Yes, sir, it can be done by T on by T. It is equal to 0.5. I can write like this. Exactly, we can write like this. Okay, sir. Now, from this, we know T can be written as, see, let me write T is equal to, observe here, T on plus T off. Can I write like this? Yes, sir. From this, I can write the expression for T off. T off can be written as T minus T on. Okay, sir. Now how will you write T? If you want to replace the T, we know T on by T is equal to T on by T equal to delta. So from this, I can say the value of T can be replaced by T on by delta. Any mistake here? This is how we are defining the delta. So if I will replace T by T on upon delta minus T on, that's all. It will become very easy now. Yes, sir. So from this, I can take T on outside, then this relation can be written as, I'm just writing the relation, right? So this can be written as 1 minus delta upon delta. Am I right? I hope you all understood how we are bringing the relation between off time and on time directly. Yes, sir. So from this, we can directly write the relation between off time and on time. Okay, sir. This is one relation. Just to do remember this. This will be helpful for you. See, you no need to memorize anything. I'm just bringing all type of possibilities. ஏன்னா sometimes examல வெறும் delta value மட்டுமே கொடுத்திருந்தாங்கன்னா on time off time மட்டும் கொடுத்திருந்தாங்கன்னா how should I bring the relation between these two people? Okay, sir. And similarly, at the same time, how should I bring the relation between T of and T in terms of T la எப்படி relation எழுதலாம்? See, let me write. This is one relation. The second relation I am writing somewhere here. See how I am writing. There are so many possibilities. It can also be written as T minus T on now. Okay, sir. Now what I will be doing here is I will keep T itself minus. Instead of keeping T on, you can replace T on by delta times of T. See, if I pass this T here, it will become delta times of T. So I can take T outside. It can be written as T into 1 minus delta. Any mistake? No, sir. Now you can choose which one is required for you. You know the value of delta. So now if you observe the question, see the output current I naught into, if I will replace this T off by T into 1 minus delta, then TT will get cancelled easily. Whole power 1 by 2. Then your answer will become very easy. You know it will be 20 ampere. 1 minus delta is 1.5. Delta is, sorry, not 1.5, 0.5. Whole power 1 by 2. So this will be equal to 20 into 1 minus 0.5. Once again will become 0.5 whole power 1 by 2. 0.5 can be written as 1 by 2. So see, can write like this 2 by root 2. Any mistake? No. 1.5 can be written as 1 by 2 whole power 1 by 2. So it will be 1 by root 2 only. 1 by root 2 is 0.707 into 20. So it will be 7.07 into 2. Or I can say it will be 14.14 ampere. So successfully we got the answer. Yes or no? Yes, sir. So what is the answer? 14.14 ampere is the freewheeling current flow through the RMS current, output RMS current that is flowing through the freewheeling diode. Now if I am asking the output average current that is flowing through the freewheeling diode, what will you do? That is also very simple. T off can be replaced by 1 minus delta times of T by T. It get cancelled into output current I naught. Output current is 20 ampere. 1 minus delta will be equal to 0.5. See, delta equal to 0.5. 1 minus 0.5 will become 0.5. 0.5 into 20. I hope it will be equal to 10 ampere. So the value of average value of the output current that is flowing through the freewheeling diode is 10 ampere. What you have to do is now repeat the same thing for this switch. Calculate the output average current that is flowing through the switch, output RMS current that is flowing through the switch. Estimate these two values such that you will get the clear idea how to evaluate these circuits. Okay, it's very easy, but you must try it by yourself such that you will get the clarity about this circuit, how to explore this type of question when it is given. Okay, so let me bring the next question now. Yes, see, given it is the chopper shown in figure. The chopper circuit shown in figure operates at a frequency of f equal to 200 Hz first, and on time period of this circuit, you know on time means, you know the meaning of on time, 5 millisecond that is given. Now The average value of the load current. Load current means output current. Average value of the guys, one more thing I would like to tell you. Sometimes exam on the inductor current க்கும் IL தான் போடுவாங்க. ஸோ ஆவரேஜ் வேல்யூ ஆஃப் தி லோடு கரண்ட் அப்படின்னா I0ன்னு போட்டுக்கோங்க. இண்டக்டர் கரண்ட்னா அவங்க மென்ஷன் பண்ணியிருப்பாங்க சார், அப்படியே வெறும் ILன்னு கொடுத்துருப்பாங்களா? நோ, தே வில் பி மென்ஷனிங் தட் இண்டக்டர் கரண்ட் அவங்களே கொடுத்துருப்பாங்க. அதனால கன்ஃபியூஷன் ஆகாதீங்க. இங்க எந்த டேர்ம் யூஸ் பண்ணுறதுலாம் மேட்டர் இல்லை. டேட்டா கிளியரா கொஸ்டின் என்ன கொடுத்துருக்காங்க அதை அப்படியே கலெக்ட் பண்ணுங்க. இண்டக்டர் கரண்ட் யூ கேன் ஃபாலோ யுவர் ஓன் நோட்டேஷன். Okay. Okay, sir. The average value of output current is given as 10 ampere. They told that with the peak to peak ripple current is given. Good question. Peak to peak ripple current. Peak to peak ripple current. Peak to peak ripple current is given as 5 ampere. Now the question is, what is the average value of the current that is flowing through the diode? Average value of the current that is flowing through the diode. So let me draw the circuit. So they have given DC supply, then it is connected with a switch, then they have considered a freewheeling diode here. I hope you can identify this type of the circuit. What is this? Anybody? This is the general circuit, or we can call it as what? Step down chopper. Circuit is clearly telling that the given circuit is what? It is step down chopper only. So voltage, input voltage, is it given in the data? Wait. Yeah. So input voltage you can consider it is, that is 250 voltage. It is given. Output resistance already given in the question. So this is 5 ohm resistor, and across this only we are going to measure the output voltage, and the value of the inductor is given as 25 millihenry. Current will be flowing through this circuit. Okay, now this is the freewheeling diode. Okay, not it is, so simply I'm considering it as a diode. Now the question is, what is the average value of the diode current? நம்ம லாஸ்ட் கேஸ்ல பார்த்தோம் இல்லையா, எப்படி வர்றதுன்னு நான் சொல்லி கொடுத்தேன். எவ்ரிதிங் இஸ் given. Okay, now it's time to explore this answer by yourself. Don't ask the question anyone, because everything is available in the question. It's very easy to bring out the answer by yourself. With this we will be wind up the class, but I'm expecting it will be done by you people. If you give the answer, happily we will end up the class, because I taught everything. நம்ம முன்னாடி பார்த்த क्वेश्चनல தான் கிளியரா சொல்லி கொடுத்தேன். கால்குலேட் பண்ணுங்க. Average value of the current flow through the diode is what? Fast. You can take 2 to 3 minutes. Just do it and try to drop your answer. Anyone got it? Eight. Geeta. Good. Any other answers? Any other answer? what happened? It is disappeared. I'm hoping that all of you are trying. Just drop your answer. Don't take much time. As usual, output current is given, peak to peak ripple current is given. Use only the data that is required for you. I'm repeating many times. Don't consider all the values, sir. They have given this, how to use this. T on and T or same, sir. Really? T on is 5 millisecond. If I will take reciprocal, it will become 1 by 2. Oh, nice. Okay. 1 minute. Good. Reduce that value. No issue. Maybe I might be entered the wrong data. Make it 100. 100 hits. Now you can proceed. Wait. It's better you can go to 150 hits. Yes, Gauri Sugumari. Yes, you guys are correct. Do it now. And your answer is correct. When T on and T both will be same, diode will not be in conduction. Current will be zero. Gauri Muthu. Your answer is correct, ma'am. As per the given data, your answer is correct. Now I have changed the data to 150 Hz. Drop your answer now. Anyway, you guys are doing it properly. That's great to see this. When on time and fundamental time both are equal, then what will happen? Inductor will be continuously charging. We will not be allowing the circuit to what step down. So data might be wrong. You can change it. Okay, you can just follow 150 Hz. Chalo, I hope I'm strongly believing that you all people can do this. I'm not going to solve this question because it is same as the last question. There also I have explored average value and RMS value both. What you have to do is do everything for this question, calculate all the parameter. I just wanted to know. Let me tell you, do everything. Calculate. Take first the diode, freewheeling diode. Find out the average current flowing through the freewheeling diode. Then again find out the RMS current flowing through the freewheeling diode. Then again take this switch, calculate the average value of the switch current. Again calculate the RMS value of the switch current. Do it slowly. I am not asking you to do in hurry burry. Okay, do it slowly, properly do it. Then calculate the output power. I just wanted to know the output power also. Okay, estimate all these parameters. Drop your answer in our Telegram group. Okay. So this is all for lecture. I'm repeating one more time. If you haven't completed the basics of chopper circuits yet, kindly go through everything because it's very important to know some fundamentals. Just go watch only one of our lecture, at least how to evaluate chopper circuit, because I taught the general procedure only. You don't need to memorize anything. For each and every chopper, I had given the generalized procedure, how to develop the output voltage expression, how to bring the relation between all the parameters, ripple to ripple current. If you understand only one chopper, how to evaluate all those things, then that automatically you can do for all other chapters, all other choppers. You don't need to memorize anything, okay? But try to observe our lecture one more time if you don't remember anything, if you are stucking while solving the problem. Fine, sir. Sugumori got 1.66 ampere. Very good. See, try to evaluate all other parameter, whatever that I told you, right? So this is all for this lecture. Remaining things we will see in the next class.